Dear friends, once again welcome. Now let us solve the question of truss through the method of joints. And let us read the statement of the problem. So determine analytically the axial forces in the bars of the plane truss suspended and loaded as shown in figure. Okay, so this is the plane truss. That's why we're talking about x-axis and the y-axis, and you can see how this structure is founded. So this is the foundation here, foundation. Okay, and there is a P force. There is the only force P is applying in the structure at B vertically, and one can see the numbers means number of members in the structure. So 1, 2, 3, 4, 5, 6 members, or you can say bars. Okay, so क्या फाइंड आउट करना है एक्सियल फोर्सेस इन द बार्स. ओके, मीन्स all axial forces we have to find out. Okay, so which method we have to apply? So method of joints. Okay, एंड मैटर ऑफ सेक्शंस कहाँ पे अप्लाई करते हैं? जहाँ पे हमें लिस्ट मेंबर्स का फोर्सेस फाइंड आउट करने हैं आउट ऑफ द होल स्ट्रक्चर. ओके, and so let us start solving from the joint A. So at joint A, what is observation? No force is there. Okay, that's why the members 1 and 2 are zero force members. Okay, means if there is no load at this joint A, okay, so we can say it zero forces. And then if zero forces are there, if there is no use of these members for this structure, so why these are there? So these are the redundant members. Okay, and according to the loading conditions, according to the structure, it is made. And whenever required, suppose any other members, like we talk about member 4 or we talk about 6, becomes useless. Okay, so there will be substitutes. Okay, so you can see these are the emergency funds. Okay, like emergency funds, whenever required in the case of loadings, heavy loadings, and some members got failed. In that case, it may substitute. It may means the members, or you can say bar 1 and 2. Okay, so mathematically F1 and F2 is equal to 0. Okay, now where should we have a focus then? Now the joint B. Okay, so equilibrium at applying equilibrium at joint B. Okay, and see joint 4 is inclined by 45 degree and P is vertical here. So let us apply the equilibrium conditions here. Okay, so if we talk about the summation of fx is equal to 0, so what will be the direction f3 with minus. Okay, and what about the f4? It is also with minus sign. Okay, and what about the angle? So this angle is 45 degree, as the 45 angle it is making with the foundation 45 degree. That's why this angle will be also 45 degree, and it is the horizontal component, so that's why cos 45 degree is equal to 0, means f3 minus then 0.707 f4 is equal to 0. Okay, and what about summation of fy is equal to 0? So we get here by this minus p. Then what about direction? So this will be also the f4 and sine 45 degree. Okay, so here one thing at b this is f3, this is f4, and it is p. Okay, so one thing here one should observe, all the forces are means the axial forces, this one f3 f4 are taken tensile, as tensile, because we don't know whether these members are subjected to tensile forces or compressive forces. Okay, so that's why we're taking initially tensile, and what we get, it's a value in the magnitude form with positive and a negative sense, that will means justify that. Okay, means suppose we get positive, then it's okay, means our assumption is correct. If we get f3 is equal to minus value, then the direction will be compressive, not the tensile. Okay, so we have equation 1 and this is the equation 2, and from both equations 1 and 2, if we solve, then what we get? So we get f3 is equal to p, and f4 is equal to minus 1.414 p. सो जैसा कि देख सकते हैं f4 इज विथ निगेटिव साइन, तो क्या हो जाएगा, ये देयर इज अ कंप्रेसिव फोर्स एक्टिंग इन द दिस बार. ओके, सो नो नीड टू वरी, इसको फिर से करेक्ट करने की जरूरत नहीं है. ठीक है. ओके, नाउ we know f1 f2 f3 f4, the rest is what? Okay, so now we have to get the remaining forces f5 and f6. We have to consider applying equilibrium condition at joint C. Okay, so this will be what? At C there is a f3, and here it is f5, and here it is f6, and what about this one? So this one it is f1, and it is equal to 0. Okay, so now, and f3 we know already, f3 is equal to p. Okay, okay, so what is the next, and what about this angle? So it is 45 degree. So by satisfying the equilibrium condition, means summation of fx is equal to 0, then what we get? We get f3 minus f6 cos 45 degree, and it is equal to p minus f6 multiplied by 0.707 is equal to 0. This we can write as 0.707, and f6 is equal to 0. So this is the third equation. Okay, and what about the next? So next, suppose we satisfy the equilibrium condition for the y directions. So it is the sum up of y direction forces. Okay, so what we get? So minus f5, and it will be also minus f6, then sine 45 degree. Okay, so this can be written as the minus f5 minus 0.707, and the f6 is equal to 0. So this is our fourth equation. Okay, so by solving equations third and fourth, what we get? So we get f5 is equal to minus 5 and F6 is equal to 1.414 P. And at the last, at the same place, better to write what we got. So F1, F2 is equal to 0, and what about F3? So F3 is equal to, we have P. Okay, and what about F4? So F4 we have minus 1.414 P. Okay, so, and what about F5? It is equal to minus P, and F6 is equal to 1.414 P. Okay, so two forces means F4 and A5 are in compressive nature. Okay, means the members subjected to these forces are in the compression. So in this way we can and this is known as the nature of the force. Okay, either compressive or tensile. So in this way we have done this, and what we did. So in this question, firstly we identified the zero force member at A. Okay, because at this joint no force is acting, that's why the force member 1 and 2 are zero force members. Okay, and why these are known as the redundant members, and what are the advantages? So whenever required, suppose any of the active members like 5 3 suppose becomes useless, then we need to have substitute. Okay, so these are like substitute. So these, so that whatever the means our structure may be subjected to heavy loads, heavy pressures. Okay, so to cope up that, these redundant force members are required. Then क्या करना है हमें? At B and C, these are the only two joints. ठीक है, यहाँ से start करें, and what are the unknown forces are there we can get. तो आप स्टार्ट वहाँ से करें जहाँ पे लिस्ट मेंबर सब्जेक्टेड हो. जैसे बी पे कितने मेंबर्स हैं? बी पे this one 2 to already 0 हो गया. Then member 3 4 and P, 3 forces are there. And what about at C? 4 forces are there, but 1 is also 0. So here also 3 forces. Okay, so आपको वहीं पे स्टार्ट करना है जहाँ पे आपको जितना आसानी से आंसर मिल सके. ठीक है, तो ऑब्वियसली जहाँ पे लेस मेंबर्स इन्वॉल्व होंगे, देन इजली यू कैन गेट द आंसर. Then go to the next joint, like we started from B, then we ended with the joint C, and ultimately in the analytical manner we found out the unknown forces, the axial forces. With this, thank you.